So what I wanted to do is I wanted to talk about the laws of thermodynamics, starting with the zeroth law. There are four laws of thermodynamics. They go the zeroth, the 1, 2nd, 3rd. And story has it, I don't know if there's any truth to it, I've never done any research on it, but it said that they've come up with the first 3 laws, 1, 2, and 3, of thermodynamics, and then they realized that they needed to talk about another law, another thing to tie them together, something fundamental, something foundational. So they came up with the zeroth law of thermodynamics to just kind of say, look, this has to be true for all these other things to be true. That's just a story. I don't know if there's any truth to it, but I've never seen any other zeroth law of thermodynamics or zeroth law of anything. So there may be some truth to it. Excuse me. So the third law, or the zeroth law of thermodynamics says that every object in the universe is trying to achieve thermal equilibrium. Now, thermal equilibrium is just a fancy way of saying everything is trying to achieve the exact same temperature. So if you leave an object into a room, that object eventually will achieve the exact same temperature as the room itself. That's basically the zeroth law of thermodynamics. You've probably already talked about this if you've looked at chemistry before. It's very common in chemistry, talking about transferring energy from one source to another, that you look at the temperatures. So what I've did is I basically put up a diagram saying here's 2 containers that are isolated from this system. They're connected by a metal bar, and this one may have a higher temperature and a lower temperature here, but if time passes, both objects will experience the exact same temperature. Okay? That's the zeroth law. It's the same thing as like a calorimeter. If you take an object and you put it into a styrofoam cup or something like that that's filled with water of a known temperature, okay? If you drop something in that object of a different temperature, that both this new object and the water will experience the exact same temperature. They get to a thermal equilibrium. Now, to achieve thermal equilibrium a little faster, what we do in calorimeters is that we put a little mixing device at the bottom so that the water is thoroughly circulated. So the object is not just here radiating the heat here and then eventually expanding. If you spin the water, it allows the water to move and to get equal exposure to that hot or colder object. So that's what a calorimeter does. It relies on this zeroth law of thermodynamics in order to, achieve this thermal equilibrium, to justify measuring the temperature of the water and how it relates to the temperature of this object. Okay? And from there you can determine energies. So that is the zeroth law of thermodynamics. It's a foundational law. It's critical to most of when we study thermal physics. We have to start with that idea that things are trying to achieve the exact same temperatures.